Okay. Good afternoon, everyone. My name is Brian Keller. I'm a technical evangelist for Visual Studio Team System. And thank you for coming to the very last Mix session of 2009. I thought it was particularly apropos that I'd be talking about testing for the very last session because as you know, the reality is that unfortunately testing gets pushed off to the end of our projects all too often. And so that's something that we're trying to change. If you study the data that shows how expensive it is to fix a bug while you're developing it versus having a customer go out and find that bug, you can just see that it's exponentially less expensive to fix it in development than it is to actually ship a bug out to the customer. So I'm going to be showing you one of the new things that we're doing in Visual Studio Team System 2010 to really help you test your applications more effectively. And so this is just the tip of the iceberg in terms of what we're delivering in Visual Studio Team System 2010. If you like what you see here, I would encourage you to please fill out the evaluations so that we can get some more testing content for you at PDC and at future Mix conferences, because it's one thing to go out and design. We've been hearing about great user experiences and really design the workflow of your application and speak in terms that users understand. But at the end of the day, if something breaks or you come up with a wrong calculation in your shopping cart and that ends up costing your customer additional money or you additional money, then really all the user experience investment in the world won't help solve the fact that your application is broken. So without further ado, today we'll be talking about a new type of automated functional UI testing that we'll be delivering in 2010. One of the first questions I always get is what platforms we'll be supporting. I want to point out that this is our current proposed set of target application stacks that we'll be providing support for. So primarily you'll see that we have first-class support for web applications, Windows Forms applications, WPF applications. In the future, we want to provide first-class support for Silverlight applications, and we're also partnering with some other teams within Microsoft and some third-party teams as well to deliver additional support for enabling the type of experience that I'll show you today. And once again, please remember to fill out your evaluation forms. That is all I have for PowerPoint, so let's jump right into some demos here. This is the new Visual Studio 2010. How many people have had a chance to play with some of the pre-releases of Visual Studio 2010? Not a lot. Okay, so for the first time, this is what you'll be looking at. You'll notice that right off the bat, we've invested in WPF for the shell of Visual Studio Team System 2010. And so it really offers us a great many options for amping up the user experience. And I'll point out a couple places along the way. But today we're going to be talking about software testing. So let me create a new type of test, and that's the coded UI test. We'll add that to our application. And a coded UI test is the type of test that you would use if you were going to basically create a functional test for either a web application, WinForms application, WPF application, and you want to add this test to your test suite to go through and validate a set of scenarios works, and then we can add some validation logic to this as well to make sure that we're not just clicking through the application, but that certain values are correct. So I'll be taking you through a very simple demo. To get started, I'll use what's called the recorder for these coded UI tests to actually walk through my user experience and just go through the steps that we expect a traditional user would use for our application. So we use the recorder here. And we have just a basic calculator application that we'll be testing, nothing fancy here. It's not launching yet. Let's go ahead and start recording, actually. So here's our application. We'll go ahead and type in some values. And one of the things to point out right away is that right now I'm tabbing between fields here. So I type 20, I hit tab, I type 10, I hit tab, I went to add, and we'll press enter there, press tab again, we'll subtract. And so just remember that when we take a look at the code that gets generated here. And then for multiply and divide, we'll actually just click directly on those buttons. And so now we've tested all the functionality of our basic calculator. And what happened here is in the background we used MSAA, which is essentially the accessibility controls that ship with Windows, and we used that to generate what's called an action log. And so down here, it's probably a little bit difficult to see, but what you see here is every single action that the user clicked on. So I typed tab, I typed in a value, I hit enter, I clicked here, I clicked there, and that's all captured right here for me in the coded UI tester. And so at this point, I'll give this method a name. Call it enter data. We'll say generate method. And so what the coded UI tester is doing is it's taking that action log and it's converting that into C# code for me. You could also convert that into Visual Basic Code if you wanted to. But this is going to become the basis for my functional test that will run over and over again just to make sure that our application works correctly. So if you're familiar with the way that unit tests get generated within Visual Studio, the syntax looks very similar. But instead of tagging this as a unit test, we're tagging this as a coded UI test here. If we drop to the definition here, we'll see that behind the scenes, what we have is essentially code that represents that action log that I just described. And bear with me. There's the code. And so what you see here is that right away, one of the things that I did is I clicked on the desktop and I pressed enter to launch the application. But the reality is that that's not necessarily going to be reliable when I want to run this test again, because I might have different windows that are open, I might have a different desktop configuration, I might not have the icon on the desktop when I'm testing it. So instead what you can see is there's another search parameter here for launching that application just by going straight to the path on the C drive. And so we'll actually get rid of this extraneous clicking because we don't need to make our test more fragile by relying on anything that sits on the desktop. So instead we'll just use the coded UI test mechanism of searching for that application on the C drive here. And as we scroll down, you'll see that every one of the steps that I performed during that demo is now converted into code, and it's also nicely attributed with some comments here that tell me exactly what I did. So I typed 20 into the text box, I typed tab, pressed enter, clicked on the multiply button. And so I pointed out earlier that there was a distinction between when I was tabbing between controls and when I was actually clicking on controls. Now, this is important to be very deliberate about because you might want to change the layout of your application later. For example, you might want to rearrange controls, and you don't want to have your application be dependent on the tab order of those controls when you're running your test, because otherwise, if you change the layout, then you may have to go back and re-record your tests. And so one of the things I can do, once again, to make my test a little bit less fragile is I can just come in here and delete everywhere that I've tabbed between the applications. And so instead of tabbing between those applications, what it will do is it will use additional search criteria to invoke the individual controls on those forms. And so once again, that makes my application a little bit more robust. And so basically what it's doing here is it's searching by control name. And so the particular control name here is called button subtract. And so this is another point to remember when you're going out and building your applications. It's important to give your controls meaningful names, because when you're going back and recording the test for these applications, it's going to be very important for you to understand what the individual controls are, as opposed to button 1, button 2. That's going to just make your job harder when it comes time to write these tests. And so at this point, I could go ahead and run my application. There is a performance fix that I need to do for this particular build. So you won't have to do this in the actual release of the software. But I'll just add this performance fix. And before I run this test, I will also show you the test run settings for this particular test. And so test run settings have a lot of different options for configuring the way that I want my test to run. But most importantly, in 2010, we're introducing a variety of what are called data collectors. And so if I take a look at these data collectors, one of the things that we're trying to eliminate is the no repro scenario. How often does a tester find a bug and then file that to the developer, and the developer looks at that and says, well, you know, it works on my machine, or I don't have enough information from this tester to actually reproduce this bug. And so one of the things we're trying to bake into the developer and tester handoff within 2010 is to collect as much relevant information about the test that we're executing, and then automatically pass that back to the developer. So for example, one of the test collectors that I have turned on right now is called system information. So let's assume that my tester was testing on IE6, and we know that we only support our application on IE7 or IE8. Right away, the developer can get that information. They don't have to go tap the tester on the shoulder and say, hey, what browser were you running? We don't actually need that for this particular demo, so I'll turn that off. A couple other collectors to point out down here. One is the test impact collector. Test impact collector can run behind the scenes on your managed code applications, and it can actually line by line tell you exactly which parts of your application are executing when you're conducting your tests. So why is that important? Let's say that as a developer, I go back and I change 5 lines of my software application, and I want to then understand which tests were impacted by that. That might be unit tests, that might be manual tests, that might be coded UI tests. Now all of a sudden, instead of knowing that I have to run my entire test suite, I just run these 5 impacted tests or whatever the case may be, and that really helps me focus the scope of my next test pass. Another one that we can turn on is a video recorder. So for a coded UI test, this isn't quite as interesting, but for a manual test, you might want to have the tester running through the test and have a video recorder enabled, and that can actually get attached to a bug as well. So as a developer, I open up the bug, and I jump straight to the video that shows me exactly what the tester did. I don't have to guess if the tester clicked on the right button or exactly what the bug looked like. I get all this rich information at my fingertips, and again, let's eliminate that no repro scenario. Because the problem with the no repro scenario is you're wasting the tester's time because they just went out and found a bug. The developer can't reproduce it, so you're wasting their time. And at the end of the day, there's still a bug that exists in the software. So again, we want to give the developers as much information from the testers automatically so that they can root out these bugs. So we have our collectors disabled for this particular test. So I'll just go ahead and apply those test run settings. And at this point, I want to just run through my test. Now, we're not actually validating anything at this point. At this point, we're just going to be running through the application. And you'll notice I don't have my hands on the mouse or keyboard. It's going to open up my application, and it's going to enter that data automatically for me. And it's going to click these buttons, and it's going to throw an exception. That's not part of the demo. So I think that I must have fat-fingered something in here. Let's see if we can get this. I've got a backup solution. But basically at that point, you started to see it going through and entering the individual data into the text boxes and pressing the buttons. Again, we're not actually validating anything at that point, but what we're doing is we're going through the same steps that I ran through when I recorded the walkthrough of the application. So this is my completed application. So I just want to show you how we add validation logic. We have about 6 minutes left, so I'll just take you quickly through that experience. So validation logic essentially gets added the same way that you would go through and record the steps of clicking through the application. So if we go back into my coded UI test here, we can use the UI control launcher to actually determine which elements of the application I want to add for validation. So what I'll do is I'll launch this application once again. This is my calculator, and I can add a new UI control element, and I can use this crosshair to actually select the individual elements of the application that I want to validate. And so here it's just browsing the basic Windows Forms control. If you were using WPF, it would be going through and validating each element of the WPF control. If you were using a web application, it would actually be inspecting the DOM at this point. And essentially, it's doing the exact same thing that you would do for a web application. So on an IE DOM, you might get a different experience than with a Firefox DOM. And so you might actually want to write two different tests, one that validates IE and one that validates Firefox. So I've already added that to this application. So let's go ahead and run through the final experience of testing this. And the one other thing that I've done for this final solution is I've data bound this to a text file. So instead of going through and just entering 20 and 10, I might want to enter a wide array of data. I might want to check particular edge cases to find out what happens if I do a divide by 0 and make sure that the app handles that in a smooth fashion. But for this particular application, we just have two different test cases. And if I drop back to Visual Studio here, and I run through my test, then what you'll see is it's going to actually run this test twice, once for the first set of data and then once for the second set of data. And so that's a coded UI test. Down here at the bottom, you can see that the test passed. It's actually saying that 3 of 3 test passes. So we had 2 data sets, and then it counts another test case for the overall test container. So that's coded UI testing. If anyone has any questions, I'll be around. But that's something to look for Visual Studio Team System 2010. And we'll also be posting additional videos on Channel 9 if you want to explore some of the other aspects of testing with Visual Studio Team System 2010. Thank you very much, and we'll see you at next Mix.